MongoDB as a database. So far we have been using files, and that's not how a real enterprise manages data. Usually we use some kind of database. So far, maybe in the course 351, you have seen a relational database. I think you have seen Oracle. But in this course, we will see a different kind of database called MongoDB. So what you have seen is called the relational database. And those relational databases, the main thing you find in a database are tables. And those tables have relationships. And the tables, as you know, have columns and rows. Now, the reason why we're using MongoDB is because what? Anybody can tell us why MongoDB rather than something like Oracle or a relational database? Open source, yes, but there are a lot of relational databases that are open source, like Postgres and MySQL. So that's not the real motivation. Any other idea? So far, the files that you have been reading and writing from, what they contain, what's the content of those files? JSON objects or JSON documents. So relational databases, they are not very good in dealing or managing JSON data. They are usually good for, I'm trying to be close to this microphone, they are more designed for tabular data. That's what relational databases are good for. And these tabular data, of course, they can have relationships. So for example, here is my customer table, and here is my order table. And basically, I can have a one-to-many relationship between these two tables. Okay? Now, in a JSON, you will represent this as one document, where the customer has a list of orders in one document. You have seen this in your project. So what we had is tasks, isn't it? What we had? What was the data we were managing? Yes, it was students and tasks. Yes? No, not student and tasks. Courses and tasks. So where did we store the tasks? In the course. So the list of tasks associated with the course are stored in the course itself. Okay. So in a document-oriented data management system, we keep related data together in one document. So with relational, if you use a relational database, you have to convert from JSON to relational, and when you read it, you have to read from relational and then convert it to JSON. So it does not natively support JSON data format. And you know JSON is very popular in web development. So we send JSON to the client and we receive JSON from the client. It's all over, it's used all over the place. So we want a database that natively supports, built-in support for JSON. And that's basically where MongoDB fits in. It is it's called a document-oriented database. It's not a relational database. So what we find in a document-oriented database, we find documents, and these documents are arranged in collections. So we have collection of documents. Let's say courses, set of courses each course is a document, and these set of courses are managed in one collection called courses. We might have, let's say, books collection. We might have student collection, and so on. And they're basically same as in relational database. We have the ability to query the data using typically SQL. In MongoDB, as an example, we have an API to read and write the data from the MongoDB. It's not SQL, it's some other API and some other language to interact with the database. Okay, so, and just to give you a big picture, like in the real world, many people are using this combination of technologies that we call the mean stack. to build web applications. So on the client side, typically you may use a framework like Angular. On the server side, you use Express to build your web application, and you use a module called Mongoose to interact with MongoDB database. And then on the database layer, you use MongoDB. So that's why we call it the meme stack, which stands for Mongo, Express, and Angular. Okay, and Node.js. So this is a very popular set of technologies that are used together to build a web application. Okay, so as I explained, MongoDB, it manages data as as collection of documents. And these documents are nothing but JSON document, similar to the JSON documents you have been dealing with in files. Instead of using files, you will push these files and store them in a database, and then you can query the database for this data. You no longer use files. Because files, first of all, they are not multi-user. One user at a time can read and write to a file. Database, by definition, is a multi-user. Multiple users can read and write to the database at the same time. And with the database, you can handle millions of documents. And in fact, you can deploy your database to multiple servers. So it's very popular, very famous open source database. So I already sent you an email asking you to please download the MongoDB database. There is an IDE, like a graphical user interface to interact with the database. And if you wish, you could also use MongoDB without installing it, but this only works from home. It doesn't work from QU because the ports are blocked for security. But you might want to, it's free, it gives you 500 megabytes free. Okay, so as I explained, in a relational database, you organize your data into tables, and these tables have relationships. So for example, you have here person and cars. A person has one or many cars. This is how you store it in a database, in a relational database. In a MongoDB, you will put these together in one document. So you will say, this is the person details, and these are the cars they own in one document. And that will be in, let's say, person's collection. Okay. So the way it works, the major difference you will see, you will throw away files, you bring in MongoDB database, you put all your data, read it from the files, push it to the database once off, and you throw the files away. And then in the Node.js, which part will be affected once you throw the files and bring in the database? Which components of your application will be affected? The model, yes. Which repositories? Thank you very much. All you do is you will write a new version of the repository. Instead of, in fact, that's what you will do in the lab. That's what you will do in your project. You will take the repository, you don't change it, keep it, that's dealing with files, and you create a new one that has exactly the same functions and the same signatures, everything the same, but it will interact with the database rather than the files. Okay? And that's the power of MVC. You will not touch anything else. Everything else should work as it is. Just the repository, you go and create a new version of the repository, and then you go to, once your new repository is created and tested and you're happy with it, you go to the controller and you change one line, and you say to the controller, don't use the repository that uses files, use the repository that uses MongoDB. Yeah? Okay. Now, for us to interact with the MongoDB database, we need, of course, we can use the API that comes with MongoDB, but it's a bit harder. So that's why people created a module in Node.js. You remember Node.js? It has modules that you can download from npm and one of these, it's called Mongoose. You know that famous animal called mongoose. So that's from where the name came. It's very, very popular. Let's see how popular it is. So if I go to npm JS, just to search for Mongoose. Okay, here it is. This is the latest version, 4.9.7, which means it's very mature, and it's just released a new version 6 days ago, so it's very active. It's not like some abandoned module. And you can see here in the last month, more than million download, million and a bit more. Okay, so it's very, very popular. Okay, so now what we will do, we will study how we will basically store documents in MongoDB and retrieve them using this package called Mongoose. So what we will do is I'll drive this through basically through examples and explain how we will do that. But let me just explain one thing. So in MongoDB, as we said, we have collections. Collection of documents. And these collections have documents of the same type. So we have books collection, we have course collection, we have students collection. And within this collection, I will have documents. Could be 1 to millions of documents of the same type. These documents, they have some common schema or common structure, but they can be a bit different. For example, let's say students, some of them might not have a mobile, very rare. Some of them might have multiple. Some of them might have a postal address, others only have a residential address. But there have also some common things like ID, first name, last name, date of birth. They all have this information. So documents have similar structure, but they can have some differences. But overall, it's kind of the same structure. Now, for us to deal with these documents and to read and write them, what we do is we go to our program and create an object that will map. So we will have here an object that I call here a model that will map to the document. So what Mongoose allows me to do is it allows me to create a model, and what I use the model for is to interact with the document. So the model, it makes it easy for me to read and write documents. So let me explain this part through an example and then come back and explain it further. Okay, so let me open okay. Here is my example going on here. So if I want to use MongoDB, the first thing I need to do is for each document type or for each collection I have in my database, I will go ahead and create a schema. What a schema is, you know what's the meaning of a schema? Another synonym of schema? Sorry?
So tables that are related to each other?
Yes, that's good. Another synonym for it is the structure. So for me to interact with documents, I need to know their structure. I need to know what are the properties of those documents. So first of all, let me show you how documents look like in MongoDB. Here it is. So let me just refresh. So MongoDB, as I said, is a set of collections. Sorry, it's not very clear here. I'm not sure how to increase the font. Well, let me just close this and open it again. Okay. First of all, let me explain a little bit more. So for you to use MongoDB, of course, you need to download it, install it. When you install it, you run it. And I sent you the command to do this. When you run it, it will be listening at some port. It will start listening to receive commands. So it is a server. As you know, a server is a piece of software that is running and listening for requests coming through a certain port. So MongoDB, when you start it, let me just stop this one and start it again in front of you. So to start MongoDB, I go to the place where I installed it, and I call this command called MongoD. So when I run this command from the command line, it will run the server, and the server will start listening. It's not very clear, but you can see there what port it is listening at. It's 2717017, yes? So it is listening there, and we can ask it either to store documents or give us some documents, okay? Now, what I will do, I will use this RoboMongo. I run this RoboMongo, and then this RoboMongo allows me to connect to this MongoDB that is running on the background. And you can see here which port I'm using to connect. Same exact port, 27107. So once I connect, I will see a couple of collections there. You remember, documents are organized in collections. One of those collections are books, the books collection. So in books, I have there is a books database that have two collections, books collection and stores collection. So here are the books. Books have set of documents. Every document has a unique identifier. And if I open it, it's nothing but this is a JSON document. In fact, if I view the document, you can see here the data is stored natively as JSON document, as you can see. So each book has an ID, a unique identifier that's auto-generated by the database. It has an ISBN, title, category, pages, which store it is located at. And the store, as you can see, is a reference to another collection. So I have another collection called stores, and books are maintained or managed in stores. And then they have reviews. Nobody has reviewed this book yet. When it was created, and so on. Okay? Who are the authors and so on. Okay, now the stores collection. In the stores collection, as you can see, also it is a set of JSON documents. And here, the name of the ID of the store, which is auto-generated. What is the name and which city the store is located at? And you can see the book collection or the book documents are referring to the store collection. By store, I don't store the details of the store here inside the book. I just refer to the documents in another store collection. So this is kind of a foreign key, kind of. If you remember, in a relational database, from one table I can refer to a record in another table using a kind of a foreign key relationship. You can think of it kind of similar way. Okay, now, for me to deal with this document, to read or write them, okay, for me to read or write these documents, the first thing I need to do in my program, I need to describe the schema of this document before I can deal with them, before I can read or write to them. What I need to do, I need to define the schema, which is basically the structure. So what is the schema of this document? Can somebody describe for me this document, please? ID is auto-generated, so I'm not going to deal with it because the MongoDB will generate it automatically. There is no way I have guessed that number and typed it. It's generated. So what else is there? There's a property called name. What is the data type? String. There's a property called city. What is the data type? String. Don't worry about the other one. Also auto-generated. It keeps track of the versions. As you update, I think it will be auto-incremented. I have not used that feature. So let's ignore the underscore ID and let's ignore the underscore V because these are auto-generated fields we don't care too much about. Is clear? Okay. Now, let's describe the schema of the book. Here are the books. And let me go here. Okay, let's describe the schema of the book. What do we have here? ISBN. The type is a string because it has double quote. It could be a number, but you know ISBNs can have alphanumeric values in real life. That's why I made it string. The title is a string. The category is a string. The pages is a number. Very good. The store is
reference.
Thank you very much. Is a reference to another document in another collection. Yes? Okay. Now, the reviews is an array. We don't know what it is. It is an array. But this array could have, let's say, rating and description or comments. Okay, created on is? No. It's a date. It's a date. ISO date, this is a standard format for dates. Read, it's a Boolean, thank you. Publisher, it's an array of strings. Strings, it's just strings. Sorry. Publisher is an object. The publisher is an object. That object itself has two properties, name and country. The author is an array of strings. And that's it. This we don't care about. Okay? So, for us to read or write to MongoDB, what do we need to do? First thing is describe the schema of the document. Okay. So let me show you how we describe the schema of the documents before we do anything with them, before we can read or write to them. So I go to my model and basically describe what is a book and what is a store. That's the first thing I need to do. So let's start with the store since it's simple. And this is how I describe it. And this is where Mongoose comes in. So I import Mongoose, I install it, as you know, npm install Mongoose, and then I use this Mongoose and create a schema. So I create an instance of Mongoose schema. Why do I create this Mongoose schema? To describe the schema of the document. Stored in which collection? In the stores collection. Okay? So here is the store has two properties, the name of type string and the city of type string. Okay, then I use this schema to create a model. So it's a two-step. First I create the schema, that is nothing but the description of the structure of the document. And then I use the schema to do what? To create a model. And what do I use the model for? I use the model to read and write corresponding documents. So it's a two-step process. First, describe the schema using the Mongoose schema object. So I create an instance of Mongoose and start Mongoose schema and start describing the properties and the data types. Then I use this object to create a model. Okay? So you can think of a model as a representation of this document collection in my program. So I will use this model to read and write documents from that collection. Okay, so when I create a model, all I do, I go to Mongoose and say, please create a model called store. And this model have this schema called store schema. That's all I'm doing. Okay? Now, let's do the same for the book.
We only created it here.
Sorry?
We create the schema here, not in MongoDB.
On MongoDB, it does not need schema. So MongoDB is schema-less. This is a good question. In a relational database, before you start inserting your data in the database, what do you need to do? Create the tables, basically create the schema. So you go and say, create table, student, and you define what the student is, ID, first name, and so on, and ID is primary key, and you do all of this. And then you start inserting into that table. Yes? You have seen this. Now, in MongoDB, you don't need to create a schema. Just take a JSON document and store it. No need for schema. But for programming, using Node.js in an easy way to program, you need to create the schema. So schema is not needed by MongoDB, is needed for us as developers to easily write code to read and write for MongoDB. Yes? But MongoDB does not need a schema. In fact, each document in the collection can have a different schema. But in reality, they have kind of the same shared schema with some variations, as I told you.
So if you have already a created database,
Yep.
we need to read it from here, we should create it.
Yes, you must create a schema before you can read it. This is if you want an easy way to do it, like using Mongoose package or module. Yeah? Okay, very good. Yes, please. Yes.
What can I be doing when creating tables from scratch?
Sorry?
I'm not going to be learning creating tables from scratch.
No, from scratch. So basically, let me show you. Okay, so let me just come here, remove all document, drop collection. Yes, drop collection. So when you start your server. There is no database, no connection. Let me even drop. Does it allow me? Yes, drop database. You start fresh. Nothing is created there. Okay, and then when you start your application, it will create. If the database is not there, it will create it. If there is no data there, it will populate some of the documents. It will read them from the files and store them in the database. So if you to do all of this, to create the database and to create the document collections, you need to create a schema. For each collection, you create a schema, and based on the schema, you create a model. And then you use the model to read and write to the database. Is that clear? It will come clear as we go. Now take it a bit mechanical. So first, for each collection, you need to describe it by creating a schema. Once you create a schema, you need to create a model. And what do we use the model for? To read and write to the database. Yes? Okay. So we've seen how we described the store schema. What about the book? So here is how we describe the book. The same thing, same principle. ISBN, what is the data type? String. Title, string. Authors is an array of strings. So it's very straightforward, as you can see. Publisher is an object. And then I describe what is the structure of this object. It has a name and a country. Category is a string. Number of pages is numbers. Read is Boolean. Here I can specify some properties. The default value of a read, false. And is it required or optional? Required, true. Okay. Now created on is a date. If the user did not provide this field, what will be the default value? Today's date. You see here, it's very powerful. When you create the schema, you can set some default values. Now reviews is an array of objects. Now I can either describe the object like this, or I can describe it in a separate schema. You see here, I'm describing the review schema. It has how many things? 4 pieces of information. Who added the review? What were their rating? And the rating is required and must be between 0 and 5. You can see here. And then reviews, text. This is a good book, terrible book, whatever. And the date. If the user did not specify the date, the default will be today's date now. Okay, the store. Remember the store? Is the store, what is the store in our schema, remember? Yeah, it was a reference to a store in the store collection. So how do I create a reference? This is how I create a reference. Very simple. Here I'll say the store, the data type is object ID referring to the store collection. That's how I create. That's how I do it. Okay? So that's it. You know now how to create a schema. So what I use the schema for? To create the model. What I use the model for? To read and write to the database. Is clear so far? Okay. So here are the programming steps for me to program using Mongoose. Okay. First, I need to require Mongoose, download it and install it and then import it in my program. Then I need to connect to the database. So the database typically is located in localhost, typically under the port 27107, if you remember. And then you specify which database you want to connect to. It could be, in our case, it could be books. Now, if the database exists, you will connect to it. If it doesn't exist, it will be auto-created. And then you define the schemas of your of your collections. You use the schema to create a model, and then you use the model to read and write. That's it. This is how you do it. No need for this. By the way, this is how, if I want to find all the stores in my database, all I do, I go to the model and call a method, built-in method called find. And since there is no where clause, you remember select star from student where you can put some condition. Here there is no condition, so I will get all. Okay, so that's basically how I will read. So now that you understand these basic steps, let's see them in practice. Here it is. So here is my books repository. For the controller, the app, you know how to do that. The app is exactly the same. The only difference is that I have basically go here and say mongoose.connect, and I connect to the database. If there is an error, I will tell you there is an error. Maybe the server is not started yet. If there is no error, I will initialize the database. If it is a new database, I will go to my files, load the data from the files, and push it to the database. And then I'll start listening, as I start my app.js and start listening. Okay, now let's focus now on the repository. Couple of things. So my repository need to import the models. Remember the models I created? I have two models. The store model will allow me to read and write from which collection? The stores collection. And the book model will allow me to read and write from the books collection. Now, you see in my database, there is no such thing as books database. There is no books collection. There is nothing. But as soon as I start my application, it will auto-create all. Okay, I just wasn't patient. Okay, here it is. So if I go here and refresh, the books came up, and it has two collections, the books and the stores. Okay, now, very super quick, I'll come back next time, I'll explain more, you will play with this in the lab. So if I want to get all the stores, very simple. I go to the stores model and say find, and don't put anywhere close. What this will give me? All the stores. Here, in this one, I am getting distinct categories. You know, the books have categories like fun books, programming, web programming, science, whatever. I can get all the distinct categories. Very simple. Books.distinct, and I give the attribute I want to read. Okay, here, if I want to create a new document, super easy. Get a new object and just say book.create and give it the instance of the object. What is in this new object is a JSON document that has the properties of the object. ISBN 123, the book name, the authors, all the information. It will push it in one line to the database.
Should the information be like in the same sequence as the schema?
No, it doesn't matter the sequence. As long as the attributes are there. attribute colon value, it does not, the order is not important.
The attribute should be the same.
Of course, same name. Yes, same name. Okay. Now, here I want to do a bit more and do, so this find will do kind of select star. You know, in SQL you do select star to get all the columns. If you don't want to get all the columns, you do find, and then you specify which attribute you want to read. You might not be interested to read all. And then, if this category is not null, is defined, there is something that is passed as a parameter, you will add a where clause. And you say, give me only the books where the category is equal to the category passed as a parameter. Okay? And then basically, this, you go to the query and say populate store. What populate store does, let me show you. Here, when I go to my store is an ID. But I don't want to see the store just as an ID. I want to see the whole store documents. So what I'll do, I go to my query and say, oh, please, by the way, go and populate that store and make it a full store details. So if I go here, have a look. When I go to this API, you see the store is the full details of the store, not just the ID. So how do I fill up the store details? I fill them up by calling this method called populate. Okay, now if I want to retrieve by ID, I look up a document by ID. Instead of using find, I can use find by ID and pass the ID. And then if I stop here, I will get all the attributes. If I want to just certain attributes, I'll specify which attribute using the select. Okay? Now, here is by ISBN. I know the ISBN is unique. So instead of using find, I can, of course, use find. I can say find one, because I'm sure that this query will only return one. Okay? Very, very powerful query, simple query language. In here, if you give me the author, I can find the books where the author is mentioned in the array of authors. So here I'm saying, give me the books where the author is where the author appears in the authors list. Okay? Because this is an array, I use the in function or the in operator to look it up. Okay. Update, again, super easy. You give me a new object, I will go to my model and say update, give you the ID that I want to update and the details of the new details of the book. And this will update it in one line. Okay, delete, again, one line, find and remove, and give it the ID, it will find that book and remove it. Now, reviews. Remember reviews? I have reviews is an array in the document. So when you give me a new review, I will go to the reviews array and add it. So as more reviews come, I'll go to the reviews and add that there. It's very simple. I first look up the book, go to the reviews, push the new review to the reviews list, and then save. So it's very straightforward API. So updates, I want to update a particular review. I want to update. Somebody changed their mind about the book. I look up that review and then change the rating and the review text and then save. This is if I want to empty everything. I'll say go and remove everything. And if I just want to know how many books, I can go and say book.count. And finally, this is how I populate the database. So when you load the database, I'll say, oh, by the way, I can empty it if you wish. Empty means remove everything. And then I'll go and say, give me how many books there. If there are no books, I will go and load the data from JSON and fill it in the database. So the way I do it, so I created two stores, hard-coded two stores here. And then I go through the books I read from the file and add them add them to the database in one loop, very simple loop. And that's it. That's how my repository looks like. So it's very straightforward, very simple. So what you do, you create a schema, you create a model of the schema, and then you use the model to read and write documents in a very simple way. So some methods like find to query, and update to update, find and remove to remove. It's very straightforward. You just need to play with it a bit, and that's what you will do in the lab. Okay, thank you very much. Of course, you can also have aggregate queries, summary queries, and more advanced queries that I will explain next time. Okay, thank you very much.